So in this video we're going to learn about effect of pulse width and pulse repetition frequency on maximum range. So this is the simple relation given between range and power and pulse width and pulse repetition frequencies. So as you can see in the relation, now as we have already seen pulse radar transmission pulse diagram, whenever we increase the pulse width, what happens is we miss the detection of nearer objects. That means we cannot determine the minimum range of a object or of a target whenever the pulse width is increased. For that duration we cannot measure the range, so gradually range of the object decreases. As the pulse width is more, for that long period, for that time period of pulse width, the radar transmits the pulse, so we have the wave transmitting for whole time period, so we can detect the maximum range of the object. That means the objects which are more farther than nearer can be detected and the range will be the maximum. So as the pulse width increases, we can detect the farther distance objects, so maximum range also increases. Now come to pulse repetition frequency. When pulse repetition frequency increases, that means the duration between the as frequency is 1 by time period. That means as duration as a time frequency increasing means time is decreasing. As the time between the pulses decreases, both the pulses have less time. That means both the pulses of transmission have less time to transmit, and once if one pulse is transmitted, there is no time for the receiver to take the echo signal, and immediately after the time period second pulse will be transmitted. So the time duration between these two pulses is very small, which decreases the range measured by the radar. Now the second topic discussed in this video is range ambiguity. So whenever we are transmitting a pulse, and you can see the aircraft over there and it's moving, when there are more than one targets, okay, and whenever the time period is more, that is T1 is more as compared to T2, okay, now we can receive the echo signal from the first target, and which is shown in the sinusoidal form, and we can even receive the echo signal from the second target. The time duration between those two pulses is T1, and it is sufficient that only two echo signals can be received before transmitting the next pulse. Whereas in the second case, when the time period is decreased, only the echo of the first target is received, and the second target echo is received after the time period, which will be in the dead zone, or it is not considered by the radar. So it is ambiguous. It will be in the ambiguous zone. Radar will not be able to detect the frequencies after the T/2 time period, or 2 times the pulse repetition frequency. So for a signal or for the range to be ambiguous, it should be equal to Cp times, or it is the velocity of the wave times, or velocity of the light